We're down to the end of another school week with just 3 classes to go. This is class time.
You can follow in real time on Television Jamaica's YouTube channel or on onespotmedia.com or on gojamaica.com. If you have any questions on any of today's lessons, you can send them into Television Jamaica's Facebook page or Instagram at television_Jamaica or use the hashtag TVJClassTime.
Today, we're going to have fun with CSEC Mathematics. Yes, math is fun, followed by home economics, and we close with sociology for Cape students. I'm Nikisha Hardy.
And I'm Denise Bailey, and we'll be your math instructors for this session as we tackle simplifying binomials. Let's get into it. At the end of the lesson, we should be able to combine like terms, use the distributive property to simplify binomials, use the area model to simplify binomials, and multiply binomials.
Okay, so in today's lesson, we'll be using some key vocabulary, such as simplify, terms, binomial, distribute, expand, and expression. So, Miss Bailey, there are different types of expressions. Do you remember the different types, or basically the main types?
Well, if my memory serves me right, there are numerical expressions and algebraic expressions?
Yes.
Okay.
Good. So let us get some more information on each of those types. So the numerical expressions, these are expressions which consist of only numbers and operations. Variables are never included. For example, 3 being added to 4. While the algebraic expressions, these are expressions that consist of variables, numbers, and operations. And our example, we have b subtract 3. Now, as there are different types of algebraic expressions, there are also different categories of expressions based on the number of terms. Do you remember any?
There's one that I have challenge with calling monomial.
Yes.
Okay.
Yes,
and
very good.
Binomials and polynomials.
Very good.
Those I remember.
So what do you remember about monomials?
Monomial, I'm thinking of the prefix mono, meaning one. So therefore, this is the category that has expressions with only one term.
Good. And our example, as we can see, is 2a. The binomials.
By two, as in bicycle.
Very good.
Expressions that have two like terms.
2 unlike terms, yes.
Thank you. Oh, I see. As in the example, we have 2a added to 3.
Yes.
Okay, I get you. I get you.
And I remember the third one you mentioned was polynomial. Now, the polynomial is an algebraic expression with more than one term and a non-zero exponent. And in our example, we have 3 terms, a, 2a, and -1.
But, Miss Hardy,
Yes.
when I look at the definition for the polynomial, I see with more than one term
Yes.
and non-zero component. But let's look at the binomial. These expressions have 2 unlike terms. So what does that really mean?
Very good observation. So, since a binomial has 2 unlike terms, and a polynomial is one with more than one term,
Okay.
it would suggest that the binomials are also polynomials.
Okay,
Good.
I get you.
Okay.
So to begin the conversation and to set some foundation for where we will take this lesson today, I want us to look at apples and bananas. I mean, who doesn't like apples and bananas? And so here we have some apples and some bananas.
Yes.
Good. What does that have to do with our understanding, though? So let's go. Now, if we have 2 apples and there are 4 apples, and we have 4 bananas and 1 banana, I would want us to appreciate and understand how many fruits there are. Now, if I wanted to answer the question, how many fruits are there, using the apples and the bananas, what do you think that would be?
I would have to add them.
Okay, go ahead.
Yes. So I'd add my 2 apples and 4
Hold a minute. So if I wanted the fruits, when you add them, what would be the unit, though?
I'm not sure, maybe apple banana?
Okay. I've never seen an apple banana before, but in the example that is there, I see that they are separated. We see that 2 apples and 4 apples will make 6 apples in all, and 4 bananas and 1 banana makes 5 bananas in all. So if we wanted to know the number of fruits, what would your answer be?
I would just maybe mix them up, put them together.
Put what together?
The apples with the apples and the bananas with the bananas, because we've never seen an apple banana before.
Okay. So we could probably work with that. So we would group the apples with the apples and the bananas with the bananas. Okay. So when it comes on to the number of fruits, we're going to add the 2 apples with the 4 apples, 4 bananas with the 1 banana, and together we will have a total of 6 apples and 5 bananas, speaking to the number of fruits that are there.
Yes. So I noticed that we didn't put 11 apples or apple bananas, because that doesn't exist.
That does not exist. So the unit wouldn't be apple bananas. We just have 6 apples and 5 bananas.
Because they're different.
They are different.
Okay. So now we're going to look at like and unlike terms. Now, just as how in the previous example, we spoke of grouping the apples together because they were alike, and the bananas together because they were alike. Okay. Just the same in algebra, we have like and unlike terms.
Okay.
So those that are like terms are those that have the same variables and degree. And when we talk about degree, we're talking about the exponent or the power. And this is what it would look like. So here we have 4 terms that are considered like terms because they have the same variable xy squared in each of them. Right? So the variable xy squared is common to each term. So all these 4 terms are considered to be like terms.
Noted. Therefore, the unlike terms would mean those terms that do not have the same variable or degree exponent.
Yes.
And the examples we have here, let me see if I can apply this to what is actually here. I am seeing 2x, I'm seeing 2x squared, 2y, and 2xy. Now, when I'm looking at the variables and the degree, I'm seeing x raised to the power of 1, x raised to the second power, y raised to the power of 1, and xy raised to the power of 1. So while we are looking at the variables, I'm seeing x and x, but the degrees, the exponents are different. One is raised to the power of 1, while the other is raised to the power of 2.
So even though they have the same variable in terms of the letter,
yes,
their exponents are different, making them unlike terms.
And similarly, even though we have x in the final term that is there, 2xy, we appreciate and understand that we don't have any more xy combination in any of the terms. So, of course, those are unlike terms.
Good. Sounds interesting. So, as we said, we'll be simplifying binomials today. So, let us look at an example. Here we have an expression, 7x plus x added to x. Now, we want to simplify this. So, we would get 8x. Now, looking at this, we have 7 x's, 1, 2, 3, 4, 5, 6, 7, being added to one other x, which would give us 8x. All right, so 7x added to x would be simplified to 8x.
So, and we are able to do this, simplify this because they are similar, like
They
terms.
are like terms.
X variable
Yes.
with to the x, okay. Yes.
Yes, the same exponent. Now here we have another expression. 4x cubed to be added to 2, added to 3x squared, subtracting 7 and subtracting x squared to simplify. Now, what do we need to do? You see any like terms in here, Miss Bailey?
I am looking and I am seeing like terms. I'm seeing variable x squared, x squared. So there are 3x squared and x squared. So those would be the like terms for me.
Right.
Also, the constants,
Yes.
2, negative 7.
Very
so
good.
we have grouped those. So those are the terms that I see as being like terms.
Very good. So remember, we look for our like terms, group them, and then we simplify. Now in simplifying 3x squared, subtract x squared, we'd end up with 2x squared. So our simplified version would be 4x cubed plus 2x squared subtract 5.
And we would have got the subtract 5 or the negative 5 because of the operation that happens with the constants that are there.
7.
Yes.
Yes, that's correct. All right. Now, we have been affected by COVID from March, and it has impacted our daily lives, whether financially or otherwise. Some persons have lost their jobs. Now, in light of this, the government has put in programs to assist citizens. And this one we're looking at is COVID care supporting backyard farming. The government is encouraging citizens to do backyard farming to offset family expenses. Rather, will be given insecticide sprays based on the area of the available land in the backyard. Now, this is Jason's farm. Jason is excited about this, but his farm is split into 2 sections. One part for tomatoes and the other for bell peppers. He needs to find the total area for both sections. Now the produce. Okay, let's pause here for a bit of house cleaning. Class time will continue after this break.
It's here. Interactive classes for all ages on the School Time channel on onespotmedia.com. With a combination of live Zoom classes and recorded class time, Schools Not Out lessons, and numerous educational content, we've created a comprehensive 24-hour channel dedicated exclusively to educating our nation's youth. Early childhood through to primary, secondary and tertiary, it's one stop on one spot for education 24 hours. Brought to you by the Ministry of Education, Youth and Information in association with Television Jamaica Limited.
Reduce your risk of viral illnesses like the flu and coronavirus. Wash your hands frequently with soap and water. Cover your nose and mouth when coughing with a tissue and dispose of it. Avoid close contact with anyone with a cold or flu-like symptoms. If you become ill, please visit your doctor or the nearest health center and share your travel history. The flu and coronavirus can kill. Let's protect each other. A message from the Ministry of Health and Wellness.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much.
It's here. Interactive classes for all ages on the School Time channel on onespotmedia.com. With a combination of live Zoom classes and recorded class time, schools not out lessons, and numerous educational content, we've created a comprehensive 24-hour channel dedicated exclusively to educating our nation's youth. Early childhood through to primary, secondary and tertiary, it's one stop on one spot for education 24 hours. Brought to you by the Ministry of Education, Youth and Information in association with Television Jamaica Limited.
COVID-19 tip. Protect yourself and others from getting sick by washing your hands after coughing or sneezing, when caring for the sick, before, during, and after you prepare food, before eating, after toilet use, when hands are visibly dirty, and after handling animals or animal waste.
It's here. Interactive classes for all ages on the School Time channel on onespotmedia.com. With a combination of live Zoom classes and recorded class time, schools not out lessons, and numerous educational content, we've created a comprehensive 24-hour channel dedicated exclusively to educating our nation's youth. Early childhood through to primary, secondary and tertiary, it's one stop on one spot for education 24 hours. Brought to you by the Ministry of Education, Youth and Information in association with Television Jamaica Limited.
Welcome back. Let's pick up where we left off. So, as we were talking about Jason's farm, and he's very excited about the project, but his farm, as we said, is split into two sections. One part for tomatoes and the other for bell peppers. He needs to find the total area for both sections. And this is what his farm looks like. And after doing some measurement, he got the width to be, for the width of the tomato section to be 2 meters, the length of the tomato section 3 meters, and the length of the bell pepper section 4 meters. Now, what shape does the farm looks like?
I am seeing a rectangle, but you know what is interesting? I'm not seeing the measure for the width of the bell peppers.
Okay.
I wonder why.
Okay. Well, don't worry. We'll get into that. Okay, so you said rectangular. Now, how do we find the area? Because Jason needs to find the area of the total farm.
Well, we know that the area of the rectangle would be the length times the width.
Good. So let's substitute those into the formula for finding area of rectangle. So substituting the length of 3 plus 4 as 3 plus 4 and the width 2 meters. We do our calculation following the order of operation. 3 add it to 4 will give us 7. Remember, work out the bracket first. And then multiply that by 2 will give us 14. So the area of the farm would be 14 meters square.
Yes. But when I'm looking at it, is there another way that we could probably work the area of the farm without doing the operation inside the bracket first? I wonder.
Well, knowing how your mind works, Miss Bailey, I know you know that there could be another way. What you thinking?
Yes, I'm remembering a word. I think I could distribute something, but let us go through and see what that could possibly look like.
All right. So, yes, there is another way. This is mathematics. We have numerous ways of getting to the same destination.
Good, good.
All right. So here we'll substitute our values again. So the total length of the farm would be 7, right?
Yes.
3 plus 4, 7. Now you mentioned distributing.
So we would not do the addition before we do the multiplication. If my memory serves me right, we can operate, there it is. We can operate on the terms that are inside the bracket using the multiplicand 2 that's outside of the bracket, and this is the distributive law.
Yes.
Okay.
The distributive law, yes. It says that multiplying a number by a group of numbers added together. So here we have the group of numbers added together, and to be multiplied by 2 is the same as doing each multiplication separately.
Yes.
So this is what we're saying. Taking the 2 and multiplying each term in the bracket separately. So when we follow our order of operations, 3 times multiplied by 2 will give us 6.
Yes.
And 4 multiplied by 2 will give us 8. And then we'd add 6 and 8 to give us
the 14. And so we have the same answer. So even though we've taken it a different route, we are still at the same answer. And that is good. I like that.
Very good. So distributive law is one of the tools that we're going to be using today to simplify binomials.
Okay.
All right, and remember what are binomials?
Yes.
Right.
Yes.
So here we have an example. And notice this looks like the example we had before, where instead of 2, we now have 5. But note, there's a variable inside.
Yes.
Do you think the distributive law can work?
Yes, I think it would work just the same. We would use the 5, the multiplicand, to operate on the terms that are inside. So I'm thinking, yes, that the 5 will multiply the t, the variable, and the 5 will also multiply the negative 2.
Thus, we distribute the 5. We
Yes.
distribute the 5 to each term inside the bracket. And 5 multiplied by t would give us 5t.
Yes.
And 5 multiplied by negative 2 would give us negative 10. So here we have our binomial simplified. Good. So let's look at another situation. Now we have 2 binomials.
I'm thinking that we would use the same idea.
Yes.
But we could use the terms that are in the first bracket to operate upon the terms that are in the second bracket.
Yes.
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 So the terms in the first bracket to operate on the terms in the second, or distribute.
Yes.
Yes. And so we would now have the A from the first bracket operating on the A in the second bracket, the A in the first bracket operating on the negative 3 in the second bracket, added to 5 from the first bracket operating on the A in the second bracket, and the 5 in the first bracket operating on the negative 3 in the second bracket. And that would be our distributing
Yes.
the first bracket on the second bracket.
Very good.
Okay.
Very good. And after distributing, we would multiply to remove the brackets, and A multiplied by A would give us A squared, A multiplied by negative 3, 3A, and 5 multiplied by A, 5A, and 5 multiplied by 3
Miss
would give
Heidi,
us negative 15. Yes.
You know what I'm seeing here?
Yeah, what?
I'm seeing like terms.
Very good.
Same variable, same exponent or degree.
What are they?
I'm seeing the A negative 3a
Yes.
and 5a.
Very
and
good.
those are the like terms.
Yes.
Okay, so we will operate on those like terms.
So yes, you're correct. They have the same variable and the same exponent. So we would simplify these like terms, add them to or combine them to provide 1. So after having negative 3, 5 added to negative 3, it will
We'll
give
get
us
positive 2a. Good.
And this would be our simplified form.
Okay. So let me see if we can work together using the same principle, work together to simplify these two binomials. We have in the first bracket x added to 3 multiplied by x added to 7. And we'll use the principle as explained before. Let me see. I'm going to distribute because that is what you just taught me.
Yes.
So we'll distribute the a in the first bracket, as we said before, acting upon the x in the first bracket, acting upon the x in the second bracket, as is here, and the 3 in the first bracket, acting upon all the terms in the second bracket. Yes.
And that's where we're distributing the first bracket over to the second bracket.
And that's what we do when we now expand the brackets to get x squared added to 7x, added to 3x, added to 21. And I'm looking at it and I'm seeing the like terms. Now, young people, whenever you're doing the multiplication of binomials, you have to be looking out for like terms. And I'm seeing that 7x and 3x are like terms because they share the same variable and they have the same degree or exponent.
Very good, very good. I see you have catch on to that
Yes,
concept
I'm
very
learning,
quickly.
I'm learning.
And 7 plus 3 would give us?
Yes,
10.
7x plus 3 would give us the 10x.
Yes.
And so the simplified term for the binomial multiplication would be x squared added to 10x added to 21.
Very good.
So, I passed, don't?
Yes,
Okay,
you're doing
good,
very
good,
well.
Good.
Wow, look at this one.
This looks a little different from what we have done before, but I think we can work it around so that we get something that is similar to what we have worked on before.
So
right?
this square is showing that we're going to square everything in the bracket, squaring all this in the bracket.
So multiply the bracket by the contents of the bracket by the contents of the bracket, right?
Right, you multiply it by itself.
Okay.
Yes, so when we do that, we would end up with two binomials now,
yes.
two
And
sets of
this
binomials.
resembles what we have done before.
So
Good.
notice,
Good,
as in math, you know, more than one ways, looking at the
Yes.
same thing. Good. So applying the same principles, this is what we would have. Distributing the terms in the first bracket over to the terms in the second bracket. 3y multiplying 3y would give us 3y squared. So let's do it step by step.
Yep.
3y multiplying by 4 would give us
12y.
And 4 times 3 would give us 12y. And 4 times 4 would give us 16. And before we got there, oops.
Did I hear you say that the 3 acting upon 3y acting multiply the 3y would give us what? 9y squared.
9y squared.
Okay.
Thank you. Yes. And in here, we have a lot of terms.
Yes.
And we want to crunch them, right?
Yes.
And I remember, as Miss Bailey mentioned, look for your like terms. Look for your not like terms. And that will, here we have 12y and 12y, and we get 24y.
Therefore, the simplified term, the simplified term or expression would be 9y squared added to 24y added to 16. And so it's not that hard. It's not that hard.
And that would take care of the distributive law to simplify binomials.
Yes.
So we're just going to look at another tool to simplify binomials.
Now, this is the area model, and it is useful for performing multiplications generally. But we are adopting it as we multiply binomials. And what it is, when you think of area, when you go back to primary school, you're thinking of area, you're thinking of surface, coverage.
Yes.
And so we're using a rectangle to highlight this concept. And so this is what we have to be multiplying. Now, I want us to take us from what we know back to take us from what we know so that we can apply it a little later down. So as you look at this, we're multiplying 3 units. We're finding the area of a shape, a rectangle with 3 units. 23 units, thank you, on the width and 46 units as its length.
Yes.
Yes. So the area model states this, that we can work with comfortable numbers. We are working with comfortable numbers. So we can work with the 23 units and make it more comfortable by having 20 plus 3. Remember, 20 plus 3 is the same as 23, isn't it?
Yes.
Or 20 added to 3 is the same as
thing.
23. And similarly, 40 units added to 6 units would still give us the 46 units.
Correct.
Now look at the arrangement that is there for us.
Yes.
Good? Awesome.
Noticed, and so we have now 4 rectangles.
Yes, we have 4 rectangles.
And each rectangle, we'll have to find the area for each.
And that
All right,
is correct.
Let's continue to
And
see what this
especially
represents.
for the young men who appreciate a little, appreciate the artistic bringing
Yes.
out, yes?
Yes.
The artist in them, this will help them. So for the first area that is identified, we're multiplying the 20 units by 40 units, and there it is highlighted for us. Similarly, we would be multiplying in the top right-hand corner 20 units by 6 units. We find the area for that. 3 units by 40 units, the bottom left-hand corner, and 3 units by 6 units in the far right corner.
So we have used length and width.
We have used all the length,
Yes.
all the width, if you
Yes.
look at what is there.
It's just like Jason's farm.
Just like Jason's farm.
Yes, where we
Similar.
had this. Yes, it's similar.
Awesome.
Yes.
Now, how would we find the area when the
Oh, yes.
units are separated as they are?
Okay. I'm thinking we would add them after.
Because you want to get the total,
Right,
right?
yes,
Okay,
yes,
good.
yes.
And so here we are going to just go ahead and add them for you. It's a 20 units times the 40, which would give us 800. The 20 units times the 6, which would give us 120. The 3 units times the 40 would give us 120. And the 3 units times the 6 would give us 18. And of course, we would add all the areas and we would get that grand total of 1,058 unit squares. Now, how will we use this area model to help us to multiply binomials? Let's go.
I think we can do it.
I think we can.
Yes. Let's see how we can
I think
apply.
we can. Now, here we have the multiplication.
So in this case,
First term, yes, the brackets in the first term,
Yes.
we have x added to 1. The terms in the second bracket, we have 3x subtract 2.
so I've noticed that you have
Okay.
assigned each binomial to a dimension.
Exactly so.
Yes. So
Exactly so.
So here we have our width and our length. But how are we going to
Think comfortable numbers. Think comfortable numbers. Remember, our goal is to calculate the area of the full rectangle. That is what we need to do. So, as we did before, we're going to split
Okay.
comfortable numbers,
So we're going
length
to
and
split the
width.
right. So we're going to split the terms into separate terms.
Good. And
Okay.
please note that we have our rectangles separated into those four areas.
For section. Yes.
Or 4 sections. Thanks.
So
yes.
here's our length. And here's our width.
And we can see that.
Yes.
Yes. Simple enough, right?
Yeah,
Good.
it's just like having this 40 and the 6.
Yes, it
the
is
20
correct.
and the 23.
Correct.
Okay.
So therefore, what do you think will happen when we go to multiply the first area,
Okay.
which is the x,
and
multiply the 3x?
Okay. Length times width.
Okay.
So we
Okay.
know how to multiply. When we do x times 3x, that would give us
3x squared.
And we do
X times negative 2.
1, yes.
Negative 2 would give us negative 2x.
And 1 times 3x.
3x,
And then we'd have 1 times negative 2.
which is still negative 2.
This is quite amazing.
And as we did in the example before, we would add all these areas together. When we add, we have the 3x squared.
And that would give us a total
Yes.
area.
We have the negative
Oh.
2x.
Okay.
We have added to 3x subtract 2.
But I'm seeing it I don't see how we get this x down here. How did we get this x?
Again, you taught me well. It's the like terms. We are grouping the like terms. And so when we group the like terms, we act upon, we have x and x, same variable, and raised to the power of 1,
Yes.
same exponent. And so when we have negative 2x added to 3x, we have positive x.
Good. So the like terms are still coming out, even though we have.
Even though,
we're
and that is
using
why it is important for us to remember what we would have done before, so that we can use it to help us better understand
What we're learning now.
Thank you very much.
Good.
So don't put things down, you know. Keep it going over.
Yes, that's
So
why it's important to keep practicing.
that is it.
So it's the same idea
It's
here.
the same idea here, and you can take this one and you can try it at home in your own time,
Yes.
right? So just look at it, and this is what it is.
So based on this, what would be our like terms?
Our like terms would be 4x and 5x, because it's the same variable raised to the, okay.
And that's how we would have gotten that 9x in the middle of the expression. So the area model is quite useful.
It's quite useful, and it makes it very clear.
Yes.
Makes it very, okay.
Especially for the visual learners.
Especially for the visual learners. Now we have a coefficient added to the variables here. I wonder if we'll be able to do the multiplication using the area models.
Yes, I think so, because
Okay.
it's similar. So
Okay.
here, length times width would give us 3x times 2x would give us 6x.
6x squared,
You
yes.
did it. And 3x times negative 9 would give us,
Negative 27x.
and then we would have 1 times 2x.
2x,
And the next area would be 1 times negative 9.
which would be negative 9. And of course, we would add all these areas, so we would have 6x squared.
Being subtracted, we have negative 27x.
Yes.
And we add 2x and subtract 9.
And of course, the like terms, we group the like terms because by now we know what the like terms are.
Yes.
We would see that negative 27x added to 2x would give us negative 25x. And this is a simplified binomial. This multiplication.
Quite easy.
Quite easy. It just takes a little clarification, a little clarity. Yes?
And time. Yes.
And time.
I like it.
I like it too.
Okay. So this would be maybe our last one. Yes. Looking at this, I see where we have, let's see how we can multiply this without the area model. Applying what we have learned before,
Yes.
just to test to make sure that we're still on track.
Because the truth is even though we use the area model to help us to clarify what our thoughts are as we multiply the binomials, we can also, when we are comfortable in the use of the binomials, we can go ahead without the area model to get us to this place.
Yes. Yes. So note that we take the terms in the first bracket
Yes.
to multiply the terms in the second bracket.
Yes.
So negative 2 multiplying
Negative 2x.
negative 2x, sorry, multiplying negative 2x. We have negative 2x multiplying negative y.
Yes.
Negative 4y multiplying positive 2x.
2x, yes.
Oops, sorry.
Woo-hoo. Yes.
Sorry. And then we would have continue negative 4y multiplying negative y right here. Now when we multiply, carry out the operation, negative 2 times positive 2
Is negative
4x
squared.
Negative 2x times multiplied by negative y would give us a positive 2xy. Negative 4y
Yes.
multiplied by 2x, negative 8xy. And negative 4 multiplied by negative y would give us positive 4y squared.
And
Now,
of course, we would group the like terms. And by
Look for your
now,
like terms.
ladies and gentlemen, you understand what the like terms are.
Yes.
And when we would have grouped, here we have the simplified. I mean, this is the answer. I
Yes.
mean, yeah.
Yes.
Just
And
like that.
it's so amazing. So we have looked at the distributive law,
Yes, using the distributive property to help us to simplify the binomials.
and we have also looked at the area.
use of the area model to help
Yes.
us to simplify binomials.
So, we can summarize.
Yes, we can.
So a monomial, thinking about the prefix again, mono, one, is a category of expression that has only one term. One term.
Binomial is, and we think of the prefix again, bi, as in bicycle, is an expression or expressions that have two unlike terms.
Yes. And we also looked at how to simplify binomials using the distributive law.
Yes.
And we saw where we used the terms in the first bracket to multiply the terms in the second bracket.
But what if we don't have terms included in a first bracket? We use the
area.
area or the term that is
Oh,
on its
so
own.
yes,
For example,
yes.
in the 5, acting upon
Okay,
the
I
T.
understand you now.
Yes, that's
Okay.
yes.
All right, and we also looked at
We also use the area model to simplify binomials. Now remember that the area model is a pictorial representation that helps us to clarify what we need to do whenever we are multiplying binomials. You can use it as a support as you go along, but as you become more comfortable, you can gradually move away from the area model, and because you're now more proficient.
Yes,
Isn't that so?
yes.
And that is what we really need.
yes, proficiency.
That is right.
All right.
We're talking about math.
Good. And that's all there is for CSEC Math today. Make sure you post your questions or comments to TVJ social media pages. We want to hear from you.
And remember, the best way to conquer math is to practice. CSEC Home Economics is after the break.
It's here. Interactive classes for all ages on the School Time channel on onespotmedia.com. With a combination of live Zoom classes and recorded class time, Schools Not Out lessons, and numerous educational content, we've created a comprehensive 24-hour channel dedicated exclusively to educating our nation's youth. Early childhood through to primary, secondary and tertiary, it's one stop on one spot for education 24 hours. Brought to you by the Ministry of Education, Youth and Information in association with Television Jamaica Limited.